Good morning, friends. Today, I want to solve some questions from last year's test paper of CBSE Standard Mathematics. I'll start with question 32A. Last time I have solved 31. Now I'll solve question 32A. Yeah, this is just. In my last class, I have ended up with solving 32A. Now I'll solve 32B. Okay. 32B. At present, Saurav's age is 3 years more than the square of his son Ravi's age. When Ravi grows to his father's present age, Saurav's age would be 6 years less than 13 times the present age of Ravi. Find present ages of Ravi and Saurav. Let us assume Ravi's age is small r, then Saurav's age becomes the square of his son, means r square, and 3 is more, plus 3. So let us call Saurav's age s. So s becomes r square plus 3. Okay. And when Ravi grows to his father's present age, means r square plus 3, Saurav's age would be 6 years less than 13 times of the present age of Ravi. That is 13 times r minus 6. So when Ravi's age becomes r square plus 3, Saurav's age becomes 13r minus 6. Okay. And then we'll compare the time gap between the ages of the present age and future age of Saurav as well as Ravi. We'll equate them. Okay. That gives us a quadratic, and we'll be solving them. So we have at present Saurav's age is 3 years more than the square of his son Ravi's age. When Ravi grows to his father's present age, Saurav's age would be 6 years less than 13 times the present age of Ravi. Okay, so yeah. So this is 31B. Or 32. It is 32B. 32B. Question 32B. Yeah. Present age of Ravi. Let it be small r of Saurav. This is r more 3 is more than the square of Ravi's age. I'm assuming Ravi's age is Ravi's present age is small r. Okay. So it is given that Saurav's present age is 3 is more than the square of Ravi's present age. Means square of Ravi's present age is or 3. 3 is more means this plus 3. And after, yeah. Now, Ravi is allowed to grow to his father's age. That is, Ravi's age is becoming r square plus 3. Okay. Then, at that point of time, Saurav's age would be how much? It is some 13r minus something. Okay. Yeah. So, Ravi is allowed to grow to his father's age. From r, he grows to r3, r square plus 3 years of age. Okay. So, and then at that point of time, Saurav's age will be 13 times of present age of Ravi minus something, minus 6, I think. Let me verify. Yeah. When Ravi grows to his father's present age, Saurav's age would be 6 years less than 13 times the present age of Ravi. That is 13 r. 6 is less means minus r. 6 is less than 13 times of r. Ravi's age means 13 r minus r. So we have, yeah, 13 r minus 6. Okay. 6 is less than 13 times of present age of Ravi. Yeah. Now, the time lag between these two ages of Saurav will be same as the time lag between between these two ages of Ravi. We'll equate them and obtain a quadratic equation. So what do we have? We have 13r minus 6 minus r square plus 3 is equal to r square plus 3 minus small r. Okay. Presently, Ravi is old and he is allowed to grow to his father's age means r plus 3. This is larger than this. Okay. So he is reaching, after how many years of time he is reaching this point of age? It is r square plus 3 minus r. From present, he is growing. After growing these many years, he is attaining this much age. That is his father's age. And for the same time, is also consumed by sorrow to reach this point of this amount of time. This amount of age means 13r minus 6 minus of r plus 3. Okay, this is the same amount of time which is which sorrow takes, that is Ravi's father takes. It is same as the time taken by Ravi to reach his father's age from the present age of R. Okay, so from present age, in the father's age is becoming this much. By that time, Ravi's age will be father's age. Father's present age. Okay, so this minus this will be equal to this minus this. So this is a quadratic. Let us simplify this. So let us take minus r square to this side. It is 2r square. It is the 13r. When it comes to this, when it comes to this side, it becomes minus 13r. Already minus r is there, and then minus 6 minus 3 becomes minus 9. Take it to the other side, it becomes plus 9 is equal to 0. I'm bringing minus r square to right hand side, it becomes plus r square. R square plus r square is 2r square. And then r terms 13r. When it comes to the other side, it becomes minus 13r. Minus r is present here on this right hand side. And then minus 6 minus 3 is minus 9. When it comes to right hand side, it becomes plus 9. Already plus 3 is there. So this gives us 2r square minus 14r and then plus 10 plus 12 is equal to 0. And in this, we can cancel 2 throughout. These coefficients become multiples of 2. We can cancel 2 throughout being non-zero. That gives us r square minus 7r plus 6 is equal to 0. Okay. We divide throughout by 2 being non-zero. So this gets cut off. This becomes minus 7 and 12 by 2 is 6. Yeah. Now 1 into 6 is 6 and 6 into 1. The factors for 6 are 1 into 6 and the factors for 6 are minus 6 and minus 1. Their sum is minus 7. So you can write this as r square minus 6r minus r plus 6 is equal to 0. Okay. I'm writing minus 7r as minus 6r minus r. And we know minus 6 into minus 1 is plus 6. That is a into c. Okay. This allows us to factorize this. This is from these two terms, r is common into r minus 6. And then we want r minus 6, take minus out. Minus of r minus 6. Minus is out, r remains. Plus 6 is minus of minus 6. Okay. Now is equal to 0. And between these two, r minus 6 is common. This implies r minus 6 into r minus, nothing is there means there is 1, minus 1 is equal to 0. Okay. In front of this parenthesis, nothing is there means there is 1 present as a multiplier. Okay. So r minus 6 is out, take it out. R comes here, -1. This R minus 6 is out, so -1 remains. Okay. So from here you get R minus 6 is 0 or R is 1. So that gives you R equals 6 or R minus 1 is 0 means 1. Okay. But when R becomes 1, then father's age is 1 square plus 3 is 4 years. Okay. A man is married only after 21 years. So uh, uh, we don't wish this to be 4 years to be father's age. So the right choice is R equal to 6. The right choice is R equal to 6. Have got R equal to 6 or 1. So uh, R equal to 1 implies Soros age, right? Let me call it S. Father's age. Father's age. Father's present age, of course. Father's present age is R square plus 3 is equal to 1. Okay? Right. Right. This is not allowed. Not allowed. Right? Because we wish father is at least 21 years old. Okay? That way it is not allowed. Okay. So let's go for R equal to 6. So R equal to 6 implies father's, right? Let me call Soros age S. Okay. So Soros age becomes R square plus 3. So this is 6 square plus 3, that is 36, plus 3, that is 39 years. Okay. So what are we asked? I think we are asked the percentages of father as well as son. Yeah. Find percentages of Ravi and Saurav. Okay, Ravi and Saurav. We want percentages. Okay, therefore, percentages of Ravi and Saurav are are 6 and 39 respectively. Okay, right? RS6 is the percentage of Ravi. So Ravi says is 6 and Saurav is father. His present age is R square plus 3, it is 39 years. 6 square plus 3, substitute 6 for R square 6, that is 6 square plus 3. So Saurav's age, so it is 36 plus 3 is 39 years. Okay, respectively. Ravi says is 6, Saurav says is 39. So that completes the question. So what we have done? Yeah, we are given that yeah, we are assuming Ravi's present age is small r. We are given that Saurav's present age is square of Ravi's age. 3 is more than square of Ravi's age. Square of Ravi's age is r square. 3 is more means plus 3. Okay, this is r square plus 3 becomes Saurav's present age. Saurav is father of Ravi. And then when Ravi attains Saurav's present age, means Ravi is growing to the age of r square plus 3. Then Saurav's age becomes 6 years less than 13 times of Ravi's present age. Ravi's present age is r, 13 times of that is 13 times means into r. And 6 years less means from this you have to subtract 6. Now, this is father's age at at point of time when at point of time which is Ravi attains at which Ravi attains his father's present age. Means at this point of time Ravi is attaining after 3 years age, which is his father's present age. At that point of time Saurav's present age becomes this much. Okay, means the time lag which Ravi attains after the present point of time, that is r square plus 3 minus r. It is same as Saurav's present. Saurav's age becoming this much from this present point of time. That is from this present age. Means from this present point of time, he is elapsing how many years? if this is 60 and this is 20, it is 60 minus 20, 40 years. Okay. So from this point of time, you subtract this. That is 13 r minus 6 minus of r square plus 3. This time lag is same as r square plus 3 minus r. The time lag from which the time lag when Ravi's age becomes r square plus 3 calculated from the present point of time. Okay. So it is r square plus 3 minus r years. If now it is 10 years and after it becomes of course if it is 5 years now it becomes how much? It becomes 25 plus 3 28 means 18 years. If this is 5, this becomes 25 plus 3 28 means 23 years is time lag. So this minus this also becomes 23 years. Okay. Yeah. So you subtract this from this and then you subtract this from this, you make them equal. So from here you get a quadratic and solve that. You get r equal to 6 or r equal to 1 and then r equal to 6 is not allowed. Why? R equal to 1 makes father stays with the 4 years, right? Father 1 becomes father only after getting married. So in India, a man gets married only after 21 years. So that's how father's age has to be greater than or equal to 20. Okay, it has to be greater than or equal to 21. So that's how it 4 is not allowed. Okay, and therefore you go for the other value of r, that is 6. When r is 6, smallest, that is Saurav's present age, becomes r square plus 3, that is 6 square plus 3, 39 years. So present ages of Ravi and his father Saurav are r is 6 and Saurav's present age is 39 respectively. Ravi becomes 6 years old, Ravi is 6 years old now, and Saurav is 39 years old now. So this completes. Next is yeah, we have completed 32B now. We'll go for 33. Yeah, 33 is statistics that you can yourself handle. So I'm leaving that. 33 is a statistics problem. I'm leaving that. I will enter 34A. 34A. From a solid cylinder of height 2.4 centimeters and radius 0.7 centimeters, a conical cavity of the same height and same radius is hollowed out. Find the volume and the total surface area of the remaining solid. Okay, we'll take a solid cylinder, right? Its height and radius are given. And from this cylinder, a conical cavity of the same height and same radius is hollowed out. Okay, is carved out. Okay, and we have to find the volume and the total surface area of the remaining solid. Let us look at picture 34A. Yeah. So we have a cylinder here, right? From this, a cone is carved out, okay, of the same height. This is the height of the cylinder. It also is the height of the cone which is carved out, okay. And for this cone, radius is same as the radius of the cylinder, okay. We are given radius and height of the cylinder. Okay, the question, that is data. So what are those values? Those values are 2.4 and 0.7. Height is 2.4 centimeters and radius is 0.7. 2.4, 2.4 and 0.7. Yeah. So this is 2.4 and 0.7 centimeters. Okay. Height means from here to here. From here. Okay. Yeah. So radius means this is the top of the cylinder. It is circle in shape, and let this be the point. capital A be the center of this circle, and okay, let it's for the bottom of the cylinder, let B be the center of the circle, which is the shape of the base. Okay. Now, if you join AB, it will be perpendicular to this radius here. Okay, that is height. That becomes height. Let us call this small h. So this AB, line segment AB, is also small h. Now this is slant height. This slant height. Let us call this point C, the circumference of the base, small capital C. So BC becomes radius. Let it be small r. So here also, if I call this D, this point D of the circumference, AD also is radius. That is given to be 0.7. So AD equal to BC equal to small r. Okay. Now we have to calculate volume and the total surface area of the remaining solid after carving out, right? After digging out the wood out of that cylinder. Okay, so what are we asked? Yeah. Find the volume and the total surface area of the remaining solid. Okay. Out of this, a cavity is made. A conical cavity of the same height and radius is hollowed out. Okay. Yeah. So, and we are given the height and radius. Yeah. And a conical cavity of the same height and radius. Yeah, that is the point. So, yeah. Means for the cone, the radius of cone and the radius of cylinder are same, and the height of cone and the height of the cylinder are same. So, first, let us calculate the volume. What is volume? What is volume of this cylinder? It is volume of the remaining uh, cylinder after hollowing cone. Okay. Yeah. So this is how much? This is question 34A. Yeah. Yeah. What is the volume of cylinder? It is pi r square into h. Okay. Base area is pi r square and height is h. So this is volume. Always a standard formula for a right object is a symmetric object is base area into height. So base area is pi r square. It is circle. Its area is pi r square into height. Height is h. And from this, cone is carved out. Cone is hollowed out. Okay. What is volume of cone? It is 1/3 the of the volume of the cylinder, that is pi r square h. And this cone and cylinder have the same height and same radius. That is why the volume of the cone becomes 1/3 of the corresponding cylinder, out of which it is carved out. Okay, so pi r square h is common. It is 1 minus 2 by 3 is 2/3. So it is 2/3 pi r square h. In these two, pi r square h is common into 1 minus 1/3, that is 2/3. So this is the volume of the remaining portion after hollowing out cone. Okay, and we are given R and H. R is 0.7 centimeters and H is 2.4 centimeters. So we can calculate. This is 2 by 3 into yeah. So it is if I write 22 by 7 per pi, approximately this is approximate the volume into R is 0.7 whole R square is this much into H is 2.4 centimeters. Okay. It is 2/3 into 22 by 7 into R is substitute 0.7, R square becomes 0.7 square into H is 2.4. Okay. I'm approximating the rational number pi by 22 by 7, which is rational number. So this is equal to how much? 3 cancels in this. 0.8 times this, yeah. And then you have 2 into 22 into This is 0.7 square is into 0.7 into 0.8 by 7. Okay. 2 into 20, I'm looking at numerators, 2 into 20, 2 into 0.7 whole square is 0.7 into 0.7 into 0.8. 2 cancels in this. No, this 3. 3 cancelled in this 0.8 times. Okay. Now this 7 has remained in denominator. Now this 7 cancels in this 0.1 times. So this becomes how much? 1 into 7 is 7 into 8 is 56 into 44. 222 are 44. So 56 and 44 is 4 56 are 4 6 are 24. 2 remains 4 5 are 20 22. Add 4 6 4 2. Okay. And how many points are there? One decimal place, one decimal place, one decimal place. These are all multiplied. So the total number of decimal places, 1 plus 1 plus 1 is 3. So put 3 decimal point from right hand side after 3 places. Okay. Before 3 places rather. So this is 2.464 cubic units, which is centimeter cube. Okay. Right. So what I have done, I have cancelled 3 in 2.4 and gives us about 0.8, and pi is approximated by 22 by 7, and 7 cancels in 0.7. 0.7 square is 0.7 into 0.7. 7 cancels in 0.7, 0.1 times. Multiply these two. That is 56. 7 into 8 is 56 into 222s are 44. Multiply that. Okay. This 7 has cancelled in this means in dr you have got only 1 as factor, so you get this. Okay. And you have 3 decimal places, 3 decimal places, 1 here, 1 here, 1 here, 3 decimal places, decimal points multiplied, decimal numbers multiplied gives product to have 3 decimal places, and decimal point comes 3 decimal places from right. That is point 6 before 3 decimal places. You need 3 decimal points in this product. Okay, so this is the product, and we have taken centimeters here, so this is centimeter cube. This completes the volume. This gives us the volume of the remaining portion of the cylinder after hollowing out core. And we are also asked to calculate the surface area. Okay, how can we do that? Yeah, surface area. Right. Find the volume of the wood required to, oh, not this one, this one. Find the volume and total surface area of the remaining solid. Okay, so we have to go for total surface area. Yeah, what is total surface area? Total surface area of the remaining solid after hollowing out cone. Okay, it is how much? What surface area remains? Means from this cylinder we are hollowing out cone. Therefore, this base will not be there, but this base remains. Okay, so this lateral surface of the cylinder also remains. So total surface area is lateral surface area of the cylinder, that is 2 pi RH, plus this top surface area, the top face area of the cylinder, that is pi r square. Then this is hollowed out. This base is hollowed out for the cone. So this base circle will not be there. Okay, that is hollow. That is hollow. That is removed. And this cone has formed newly, and its lateral surface area contributes. How much is its lateral surface area? It is pi rs. Okay, it is pi rs. So yeah. Again, what is total surface area of the remaining portion after hollowing out cone? It is the lateral surface area of the cone of the cylinder, that is 2 pi r h, that is the circumference of this into the height. That becomes the curved surface area or lateral surface area of the cylinder. Plus this top portion remains, that is circle, that is pi r square, plus this bottom portion is removed, bottom circle is removed. But this new cone has formed. So its lateral surface area or curved surface area is to be calculated. That is how much? That is pi rs. So we have to calculate this. So to do this, we need S. To calculate this, we need S, right? Because we already used R and H. R is 0.7 centimeters and H is 2.4 centimeters. We need S. How to calculate S? S is equal to H square plus R square. Okay? And why? Because triangle ABC, when you imagine that you have cut this cylinder vertically, you get after rolling out cone. Yeah, if you imagine that you have cut this cylinder vertically, the cut is passing through this radius, then you will get a right triangle ABC. That is right triangle because this is a right circular cylinder. Therefore, this AB makes right angle with the base. That is, angle ABC becomes right angle. Therefore, the triangle ABC becomes a right triangle in that hypotenuse square is equal to sum of the squares of the other two sides. That is H plus R. Their squares are H square R square. Add them. That sum is a square of the hypotenuse. Okay, and H is how much? H is 2.4 whole square plus R is 0.7 whole square. So this is how much? 2.4 is 576, is it? Yes. 7 is 49. 24 into 24. 576, yeah. Okay, and 2.4 means it is 5.76 plus 0.7 whole square is 0.49. So you add these two, or plus 15 8 plus 4 12 625 with point after two places from right hand side. It is 6.25. This is S square. From here you can calculate S. S is square root of 6.25, that is 2.5. That is equal to 2.5. Root of 625 is 25, and you have two decimal places here in the product. So in this square root, you have a single decimal place. Okay, so this is S. So we have got S, so we can calculate this. Between these two, you can take pi r common, pi r into 2h plus r. Yeah, in this also you have pi r common. Okay, take it out. So plus S. Okay, I have taken pi r throughout common. This is yeah, where is out 2h comes, where is out r comes, where is out s comes. So let us substitute the values of h, r, s and pi as a rational number. Okay. Okay, first let us calculate with pi as it is. So pi into r is 0.7 into h is 2.4 into 2, right? 2.4 into 2 plus r is 0.7, s is 2.5. Okay, so this becomes this is equal to pi into 0.7 into, this is how much? This is 4.8 plus 0.7, 2.5 is 3.2. Okay, this is how much? This is pi into 0.7 into, this is 8. Okay, 2 plus 8 is 0, 10 plus 1, 5 plus 3 is 8. Yeah, but for pi, let us take 22 by 7. So this is 22 by 7 approximately. Okay, pi is approximately 22 by 7. So what do we get? 7 cancels in this 0.1 times. So when you multiply all these, you get 8 into this is 176. Okay. Then you multiply by 1. What do you get? Yeah. So this is 176. Okay. 8 into 1 is 8 into 22 is 176. And here you have no decimal place. Here you have one decimal place. It is 17.6 cubic centimeter. This is squaring. This is area. Area. So it is square. Units are in square centimeters. Okay. Units are in square centimeters. So that's how we can calculate the area, the total surface area of the solid remaining after hollowing out a cone from the given cylinder. Okay, so this completes. So what we have done, uh, we are given a cylinder of height 2.4 centimeters and radius 0.7 centimeters. And out of this cylinder, a cone is carved out of the same height as that of cylinder and of the same radius as that of the cylinder. Okay, a cone is carved out. Let that cone be this one. Okay, so the cone and the cylinder have the same height. It is h equal to 2.4 centimeters. And the cone has base circle, its radius, and the radius of this cylinder are same. Means the circle base and the cylinder base and the cone base have the same radius. It is also the radius of the top of the cylinder. Okay. Now, so we know small r, which is radius of the circle, of this circle as well as this circle. Okay, let it be small r. It is given to be 0.7 centimeters. Height is 2.4 centimeters, and we can calculate the area. We can calculate the volume of the cylinder. That is pi r square into h. And from that, cone is carved out. What is the area of the cone? What is the volume of the cone? It is 1/3 of the of the cone out of which it is of the cylinder out of which this cone is carved out. That is pi r square h. So subtract this because it is hollowed out. Subtract this from this. You get 1 minus 1/3 is 2/3 into pi r square h. And substitute the values of r and h and simplify. It turns out to be this much, and this is volume, so units are centimeter cube. Next, we have to calculate the total surface area of the remaining portion after hollowing out this cone. Right? What is what kind of a region is that? The total surface of this object after hollowing out cone is what? It is formed of which surfaces? It is this lateral surface of this cylinder, that is 2 pi r, its area is 2 pi r h, plus this top face of the cylinder will be there, that is pi r square, and this bottom face will not be there because this cone is hollowed out. So this bottom face is removed. But additionally, this lateral surface of area of the cone forms. It contributes to the total surface area of the object. Okay, what is lateral surface area of the cone? It is pi r. It contributes. It is a new surface area. It is a new surface formed out of this object after hollowing out. Okay, so you add pi r s. S is the slant height. Okay, and S can be calculated using h and r by Pythagoras theorem. Okay, and out of these three, pi r is common, take it out, 2h comes, r comes, s comes, and substitute the values of h and r and simplify. Okay, yeah, and if you don't approximate pi and retain it as it is, this is you can simply simplify this. This is 8 into 0.7, that is 5.6 pi. Otherwise, if you approximate that, pi by 22/7, then the area will be this much. Okay, for pi, the approximation is 22/7, and then you simplify this. Okay, this cancels in this point 1 times, and then this is 8, and 8/22s are 176. You need you have this one decimal point here, so it becomes 17.6. This being area, units being 70 centimeters square. So this completes the next question. This is the next question. Yeah, right. It is also from mensuration. It is this. A carpenter is making a wooden toy, latu, which is conical in shape and surmounted by a hemisphere. The ratio of the height of the hemisphere and the cone is 3:4. If the radius of the cone and the hemisphere is, he says, okay, he is taking them to be same. That's why it is 2.1 centimeters. Find the volume of the wood required to make this toy. A carpenter is making a wooden toy which is conical in shape and surmounted by a hemisphere. The ratio of the height of the hemisphere and the cone is 3:4. Uh, yeah. The ratio of the height of the hemisphere to cone. So cone's height is larger. Okay, this is, if this is 3K, this is 4K. If the height of the hemisphere is 3K, this is 4K for K positive. Then height of the cone is longer. Okay, if the radius of the cone and the hemisphere is 2.1 centimeters, find the volume of the wood required to make this toy. Also find the area to be painted after making the toy. Okay, let us look at this. Yeah. Let this be the cone. Let its height be small h and radius be small r. Okay. And then on the top of this cone, we have a hemisphere. A hemisphere is a three-dimensional object. It is half of a sphere. Okay. And here we are assuming that the radius of this hemisphere and the cone, the base of the cone, are same. Let it be smaller. Okay. And we are given the ratio of the radius of the cone to the height of the cone. Okay, as 3:4. This is given, and we are also given the radius of the cone as 2.1 centimeters. So using this, that r is 2.1 centimeters, and this ratio we can calculate small h. Okay, how? Let r be 3K and h be 4K. Okay, we are given r is to h is 3:4. I'm assuming r is the radius of the cone, means of the base circle of the cone, and h is the height of the cone. Okay, from here to here. Right? So if I take r equal to 3K, because of this ratio, h becomes 4K. Okay, and we have this is equal to 2.1 centimeters. This is given. Radius is given to be 2.1 centimeters. Therefore, from here you calculate k equal to 0.7 centimeters. Okay, from here 3K equal to 2.1, you calculate k, that is 0.7 centimeters. You divide 2.1 by 3, you get k. Using k, you calculate h. H is equal to 4K, that is 4 into 0.7, this is 2.8 centimeters. Okay, so we have got radius and height of the cone. So we can calculate the volume of this cone. Okay, how? How? Uh, yeah. What is the formula for volume of the cone? Volume of the toy. Volume of the toy. Log 2 is equal to what is volume of cone? It is 1/3 pi r square h. Right? Volume of cone is 1/3 pi r square h in plus volume of hemisphere is for full sphere volume is 4/3 pi r cube. For one half of that is 2/3 pi r cube. Okay, and volume of cone is 1/3 pi r square h plus volume of hemisphere is 2/3 pi r cube. Out of these two, you take pi r square common and 1/3 also. This is 1/3 pi r square into 1/3 pi r square is out, h remains here, plus 1/3 pi r square is out, 2 r remains. Okay, 1/3 pi r square is out. So 1/3 pi r square, h remains, plus 1/3 pi r square is out, 2 remains, and out of r cube r square is out, r remains. It is 2r. 1/3 pi r square. Yeah, by r square. R square is out, r remains. Yeah. Substitute the values of r and h. R is 2.1, h is 2.8. So this becomes 1/3. Yeah, for for pi, we can take 22/7, and r is 0. R is how much? 2.1. I'm sorry. It is 2.1 centimeters. So r square is this. H is how much? 2.8. And 2 into r is 2.1. Okay, so this is equal to 1/3 into 22/7 into 2.1 into 2.1, right? 2.1 square is 2.1 into 2.1. 2 into 2.1 is 4.2, plus this is 7. 2.2 into 2.1 is 4.2, plus this is 5, plus 2 is 7. Okay. Yeah. Now this 7 cancel out. This 3 cancels in this 0.7 times. You can multiply these 3. 7 into 21 is into 22. Okay. 72 into 22. So 1, 2, again 294. 2, 1, add this 4, 13, 1, 12, 1, 4, 13, 1, 3, 12, 1, 3, 32, 32, 34. How many points are there? One decimal place, two decimal places. It is 32 points. One decimal place, and this is 1. One decimal place, one more decimal place, 2 decimal places will be in product. So that is 32.34 centimeter cube. This is volume, so centimeter cube will be units. Okay, so this gives us the volume, and we are also asked the total surface area. So it is total surface area. Find the area to be painted after making the toy. Find the volume of the wood required to make the toy. So the volume of cone and hemisphere gives us the volume of the wood required to make the toy. And find the area to be painted after making the toy. Okay. So this is the volume of wood required for making the toy. Okay, and now this toy is to be painted, so we have to calculate the area which is to be painted. Where paint occupies, that is on the curved surface area of this cone and on the curved surface area of this hemisphere. That is the total surface area of the sphere is 4 pi r square. So for the curved surface area of the hemisphere, it will be half of that. Half of 4 pi r square is 2 pi r square. And here, the curved surface area is pi rs. So the area to be painted is pi rs plus 2 pi r square. So let us calculate that. Yeah. So it is what? So area to be painted is equal to pi rs plus 2 pi r square. Why? Because for the hemisphere, curved surface area is 2 pi r square, and for the cone, lateral surface area, curved surface area is pi rs. We need s. we have 2.1 as this thing, the as r. Okay, height is 2.8. Height is 2.8. Okay. Right? height is 2.8, r is 2.1. So from these two, this is h. You can calculate s. S is what? It is square root of h square and r square. H square plus r square. By Pythagoras theorem, right? S square, the slant height will be, the square of the slant height will be sum of the squares of r and h. Okay, that's how s becomes. The square root of h square plus r square. This is how much? H square is 2.8 whole square plus r square is 0.7 whole square. Okay, out of these two, you can take 0.7 whole square common into, right? What remains? Out of 2.8, 0.7 is out, so 4 remains. So square is there, plus 1 square, isn't it? You look at the bases, 4.7 into 4, 0.7 into 4 is 2.8. And square makes AB, square is AB, A square, B square. So that's how 2.8 is 0.7 into 0.4. So I have written 2.8 as 0.7 into 4. I'm squaring it, so I get 0.7 square into 5 into 4 square. And yeah, of course, this is taken out. So you get this into this, like this. Okay, so this is square root of 0.7 square is 0.7 into square root of 16 plus 1 is 17. Okay, out of these 2.7 square is out, here remains 4 square and here remains 1. Or the 0.7 square is out, so 1 remains. So 16 adds to 1, that is 17 under root. You get, and root 0.7 square is 0.7. So this is slant height. Okay, so this becomes how much? Between these two, pi r is common, take it out into s plus 2r. Okay, pi r is out, s remains, pi r is out, 2 into r remains. This is how much pi, right? It is approximately, pi is 22 by 7, r is 2.1 into s is how much? S is 0.7 into root 17 plus 2r is 2 into 2.1. Okay, pi is 22 by 7, r is 2.1 into s is 0.7 into root 7 plus 2 into r is 2.1. 2.7 can be taken out. Okay, so this is 22 by 7 into 2.1 into 0.7 into root 17 plus what remains? When 0.7 is out, 3 remains, 3 into 2 is 6. Okay, now this is 7. Yeah, this, right? 0.7 is out, root 17 remains, and 0.7 is out, 3 remains, 3 into 2 is 6. Plus this. So this cancels in this 0.1 times. So what do we get? So this is equal to, 6, 6 plus root 7, root 17 into the 22 into 2.1 into 1. That is how much? 22 into 2.1 is how much? 1 into 22, 2 22s are 44. If you add, you get 2, 6, 4. And it is 22 into 2. Okay, 462 into 1, 462. And how many decimal places? 1, 1, 2. So it is 4.62. So this is area. So that is centimeter square. Okay. So what I did, this is 6 plus root 7 into 2.1 into 22 is 21 into 22 is 122, 22, 22 is 44 and 2, 6, 4, that is 462 and 1 decimal place, 1 decimal place are multiplied, you get 2 decimal places the product. Okay. So this completes. So this has come, these two are multiplied. So this is area, therefore units are centimeter square. So this completes. So what we have done, we are given a L2, means it is a cone with a hemisphere mounted on that. And this hemisphere and this cone have the same base, same radius and height. The same radius and same radius. Okay. Now, and the radius and height of this cone are in this ratio. And the value of the radius is given. So from this, we can calculate the value of the height of the cone to be this. Okay. Once we know R and H, we can calculate the volume of the cone, which is 1/3 pi r square H, and the volume of the hemisphere is 2/3 pi r cube. Okay, out of these, you simplify this. You know R value to be 2.1 and H is obtained as 2.8, and substitute them and simplify. Okay, so that gives the volume of the wood required to make this toy. Okay, next we are asked to paint the area, right? We are asked to compute the area which is right where it is to be painted. So go for the surface area of this. That is how much pi, the for cone surface area is lateral surface area is curved surface area is pi rs plus for the hemisphere you have to take only curved surface area, that is 2 pi r square. For the total sphere it is 4 pi r square, for hemisphere it is 2 pi r square. And simplify this. Substitute the values of R and S. What is S? S is the slant height of the cone. This height, right? And the height, radius, and slant height form a right triangle. So by Pythagorean by the Pythagorean rule, you calculate S. S becomes the square root of the sum of the squares of R and H. Okay, you can calculate S. So once you have S and R is given as 2.1 centimeters, so you can compute this product. Okay, to may approximate pi by 22/7. So it turns out to be this much. This is area, so units are centimeter square. So this completes. So with this, I want to stop. In my next class, yeah, I'll take up this question. Okay. Where we are given a trapezium and a diagonal and a line segment parallel to this parallel sides. Okay, and we are asked to compute the value of Fe in terms of Mn, where the ratio of Mn and PO, the parallel sides, is given. Okay, that we do using similar triangles. That I will do in my next lecture. Maybe by next lecture, I'll be completing all the problems of this question paper. Okay. Thank you very much. Please express your comments in the comment box, right? Please like, share, and subscribe. And if you have any doubts, you are welcome, right? My main objective is to clear your doubts. Okay. Thank you very much. God bless you.